Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Today we will do experiment number 8, which is CPU registers. And one of the CPU registers is accumulator. There are different CPU registers and one of them is an accumulator. So here the aim and objective, the purpose of this exercise is to examine arithmetic circuits that add, subtract and multiply numbers. Okay, so here we are seeing a circuit which is an accumulator. So what does the accumulator use? It basically is using a previous experiments idea what we have learned in a full adder, ripple carry full adder. So this is the 4-bit ripple carry adders circuit where we have 4-bit full adders, okay, with inputs as is A, B and carry in. We have a sum and a carry out. So this carry is connected to the next full adder, and then for the second full adder we again have A, B, C carry in, sum and carry out. This carry out, which is a C2, is again connected to the third full adder, similarly in the fourth full adder as well. So now this is a circuit of an 8-bit accumulator. Okay, we will implement this circuit in a Verilog program. So over here what happens in an accumulator is the data whatever we give to a processor from a from an input register, that data of an input register is added to the data present in the accumulator, and the result also is saved in the accumulator. So that is what this circuit says all about an accumulator. Okay, so basically here the data is entering at this location, okay, and over here the addition takes place and the result is again sent and saved in the accumulator itself. So this is the program for an accumulator circuit, okay, which I have already which I have already written it in your software, which is Quartus. So same steps as we did in all our experiments. This is your experiment over here, okay, which you can download it from your lecture section in the Blackboard. After you write this program, you have to compile it. You can either use the play button over here, or you can go to processing and select start compilation. So the software will check if there are any errors present in the program. If there are no errors present in the program, it will give you a message saying that the compilation was successful. So we'll wait for the compilation to happen, and once it is successful we will check and enter the pin numbers. So now the compilation was successful. We will go to assignments and select pin planner. The pin numbers have been entered. So once the pin numbers have been entered, we will go back to our software Quartus, and then we will select tools, programmer, okay, close this and select start. Once this reaches 100%, okay, the progress bar, you can see the result in the kit. So that's all for today for experiment number 8. Okay, I'll post this link on YouTube so that you can check the results for the program along with the screenshot of or along with the picture of the result. Okay, Assalamu alaikum warahmatullahi wabarakatuh. Assalamu alaikum. So this is your result for experiment 8. Okay, so we have over here switch 0 to switch 7, which is our 8-bit input switches, and then we use key 0 and key 1. Key 0 is used for reset and key 1 is used for clock. So first we will give input for our processor. Okay, so when I give 1, I'll have to press the clock, which is key 1. So when I press clock, the data is entered into the processor. Now this will add in the accumulator when I press the clock once more. So when I press the clock, it is added. 1 plus 0 is 0. So I'll press clock here. So it is saved in the accumulator. Now when I press clock again, 1 plus 1, it should become 2. So it becomes 2. If I press clock again, 1 plus 2 becomes 3. Okay, and so on. If I have to reset, I'll press key 0. Now I'll show you for the second switch. Okay, 2 plus 0 is 2, 2 plus 2 is 4, 6, etc. And if I have to reset, I will reset.